Hi, welcome back to LearnALOTL. In this video, we're going to evaluate this integral using integration by parts. So as a quick reminder, integration by parts is a technique where we identify a product of functions, where one of the functions is the derivative of something, so u dash, and then a second function v, and we evaluate them in this way. So we can turn it into uv minus this integral uv dash. So the strength of integration by parts, the power of this technique is really that we can take an integral which perhaps is not super convenient for us to evaluate, and we can rewrite it in terms of this second integral where we've transferred this derivative over to the other function. So that's what happens. It's become u dash v to uv dash. And in this way, we might be able to rewrite that integral in a more convenient way. So in this example, I see I have an exponential function and a sine function. I know that exponentials are very nice to differentiate. They really don't change structurally. And trig functions have this cyclical nature. So sine differentiates to give cos, which differentiates to give negative sine, which differentiates to give negative cos, so on. So here, my game plan is really to rewrite e of x in terms of derivatives of other functions, because they will essentially be the same every time, because exponentials are quite nice, and transfer those derivative operators to sine until I cycle back. So I'll have to do integration by parts twice, and then I'll get an expression for this integral. So let's see how that plays out. First, I'm going to call my integral I. So I is this integral e to the 2x sine x. And I'm going to rewrite this in the following way. So I know that e to the 2x is the same thing as the derivative of half e to the 2x. So I'm going to rewrite it like that. And I'm using this notation really to remind myself exactly what function am I treating as u and u dash, and what function is v in this case, so I won't make any mistakes in applying integration by parts. So now I'll apply integration by parts, and I get first uv, so half e 2x sine x, and because this is an indefinite integral, I ought to have a plus c here. And then I have minus this integral. So half e to the 2x, and then the derivative of sine x. And now what I can do is rewrite, so I is equal to half e to the 2x sine x plus c minus half the integral of e to the 2x and then the derivative of sine x, which is cos x. So now what I'm going to do is apply integration by parts a second time on this integral. So to apply integration by parts on that integral there, I'm going to rewrite it again, like I did before, as the integral of the derivative of half e to the 2x cos x, and then apply integration by parts. So in here, I will have half e to the 2x cos x plus another constant of integration. Let's call it c prime. I'm just going to absorb it into c in the next line. So c prime, and then minus this integral of half e to the 2x, and then the derivative of cos x. So let's rewrite that. Half e to the 2x sine x minus 1/4 e to the 2x cos x plus c, and then minus half, or actually, my mistake. We've got a minus half here and a minus half here. So this is going to be plus 1 over 4. And then the integral of e to the 2x derivative of cos x, which is minus sine x. So now I can rewrite this as, let's pull out a common 1 over 4, e to the 2x, in brackets, 2 sine x minus cos x, plus c minus 1 over 4, and then the integral of e to the 2x sine x dx. And we can notice that this integral is in fact I. So I can write that I, the integral I'm trying to evaluate, is equal to e to the 2x over 4, 2 sine x minus cos x, plus c minus 1 over 4i. So we're almost done. We can take this I and move it to the other side, and we have 5 over 4i equals e to the 2x over 4, 2 sine x minus cos x plus c. So our final answer is I equals, let's just rewrite the integral we evaluated here. So that integral is equal to e to the 2x over 5 of 2 sine x minus cos x plus c. And there you have it. So hopefully that worked example was helpful to practice some integration by parts. And with that, I'll see you in the next video.